Hello, and welcome to PreCalc Lesson 28. Today we are going to cover factorial notation and abstract rate problems. You're sure to love them or maybe not. The factorial is this little exclamation point, and what it means is that we are going to do the operation 5 times 4 times 3 times 2 times 1. Simple as that. I wish it were that simple, but you're in pre-calculus. Obviously, you multiply that out and you get whatever that number is, 120. So in pre-calculus, they're going to give you uglier problems that might look like this. And this is building up for some statistics that we're going to do a little bit later on in this class. So I really need you to get good and quick at these factorials. How do I deal with this? I don't want to have to write out this whole thing. Just takes up too much room. Did you notice that this 5 factorial right here perfectly matches the 5 factorial down here? So what I would encourage you to do is, if you have a big factorial, stop at the point where you can cancel. You don't have to write the rest. Then we can try and cancel some of these, like 3 times 2 is 6. Then all I have to do is multiply 9 times 8 times 7, which is 504. Your calculator can do these. If you want to know how, stop by student hours and I will show you so that you can check your work. Now, let's move on to the more challenging part of our lesson, which is abstract rate problems. I am off the screen. Hello. So, abstract rate problems are challenging because they don't give you numbers anymore. So, here's an example. The train traveled m miles at p miles per hour and arrived 1 hour late. So what I want you to do is stop right there before you ever go on and draw a table. M miles would be a distance. P miles per hour would be a rate. And this tells me something about the time, but I can't plug in 1 for the time. It's not 1. But it is 1 hour late. So I must work with that. So m miles, p miles per hour. What is the time? Well, the time, I don't even need this piece of information. I know time is distance over rate. Okay, so what do I do with 1 hour late? Let's hold on to that and let's see what happens next. Remember, if you have any two pieces of an equation, in this case, distance equals rate times time, you can get the third one. You don't need to get it from the problem. Okay. So let's keep reading. How fast should the train have traveled to arrive on time? So what are they asking for? They are asking how fast, that means a rate, should the train have traveled to arrive on time? Well, what's on time? If this was 1 hour late, then do I add 1 or subtract 1? Well, I'm going to subtract 1. So this would be m over p minus 1. Okay. If I subtract 1, then I will get the correct time. Do I know the distance? Well, yeah, they want the same distance. So as I read into this problem, I can figure this out. Now, I don't need any of this information anymore. I already used that. The information I need is to solve for x. So what is rate? Well, rate is distance over time. So that's going to be m over p minus 1. I can simplify this. And it is a rate, so it should be miles per hour. I know it's gross, but it's a careful reading through the problem that's going to help you get it correct. Now, my